Hey everyone, this is the solutions video for AP Calculus Homework 2.5a. We're on page 139. We're going to do 1, 3, 5, 7, 8, and 9. I was able to squeeze number 1 and number 3 up here, and then I'll work the rest of them for you as we go. So number 1, we actually did an example problem like this. It's a circle. This one has a radius 4. We did one with radius 1. But x squared plus y squared equals 16. Of course, this is a relation, not a function, so we have to use implicit differentiation. So I'm going to take the derivative with respect to x of both sides of the equation. So the derivative of x squared is just 2x, like it's always been. The derivative of y squared would be 2y, bring that 2 out front, then times the derivative of y. Anytime you have a y involved, there will be a dy dx involved. So the derivative of y is dy dx. And then the derivative of 16 is 0. So let's gather the dy dx term over on the left side, and then I'm going to move the 2x over to the right side and make it negative. Bring 2y underneath the negative 2x to solve for dy dx, and then the 2's will cancel, and dy dx is negative x over y. That's always going to be the equation for to get the slope of the tangent line for a circle, negative x over y. All right, number 3, we have x to the 1/2 plus y to the 1/2 is equal to 9. So I'm going to take the derivative with respect to x to both sides. So for x, it would be 1/2 x to the minus 1/2. For y, 1/2 y to the minus 1/2 times the derivative of y. You need to think of y as the blop. All right, this is a chain rule. So times the derivative of y, which is dy dx, is equal to 0. Going to keep the dy dx term on the left, move that 1/2 x to the minus 1/2 over to the right and make it negative. Then bring the 1/2 y to the minus 1/2 underneath, solving for dy dx. The 1/2's will cancel, so you have negative x to the negative 1/2 over y to the negative 1/2. However, we want to make our exponents positive, so we're going to move that y to the negative 1/2 up top. That'll make it y to the positive 1/2, and move the x to the negative 1/2 down bottom. And so I would accept any of these answers, negative y to the 1/2 over x to the 1/2. Or even prettier if you make that 1/2 into a radical, so negative root y over root x. Or what the book would do is replace the two radicals with one negative root y over x, which is probably the prettiest of the three. But I would accept any of those three answers. All right, let's work on number 5. Okay, number 5, we have x cubed minus xy plus y squared is equal to 4. So I'm going to take the derivative with respect to x of that entire relation. So x cubed would be 3x squared, then minus. And I've got to be careful here. That minus, we have to distribute the minus across the whole thing. So let's go ahead and put a left parenthesis there. It's the first, x, times the derivative of the second, that's dy dx, plus the second, y, times the derivative of x, which is just 1. I'll close the parentheses there, and we'll distribute that negative sign in a minute, plus y squared would be 2y dy dx. Don't forget, anytime there's a y, there will be a dy dx, is equal to 0. So I have 3x squared minus x dy dx minus y plus 2y dy dx equals 0. Now we need to gather the dy dx terms on one side. I'll pull them over to the left. They're already on the left. And now let's push the non-dy dx terms over to the right. So that'd be negative 3x squared, and then change the sign, negative y to plus y. Factor out a dy dx. So negative x plus 2y. We're almost done. Now we're going to solve for dy dx by bringing the negative x plus 2y underneath, dividing both sides by that. And that is the answer. All right, so you might have it y minus 3x squared over 2y minus x. Totally fine if that's the way you have it. Just depends on how you wrote all this down. But there you go. All right, on to number 7. So number 7, we have x cubed y cubed minus y equals x. All right, we've got something on the right other than a constant, so that's good. We're going to take the derivative with respect to x. Okay, we're starting out with a product rule. Okay, the first, x cubed times the derivative of y cubed. That'd be 3y squared, then times the derivative of y, dy dx. Okay, we're half done with this product rule. The first times the derivative of the second plus the second y cubed times the derivative of the first 3x squared. Now we'll clean it up a little bit in a little bit, but times the derivative of the second 3x squared minus what's the derivative of y just by itself? It's dy dx, and the derivative of x is 1. All right, let's gather the dy dx terms, and I'll probably consolidate this step in a minute because it's pretty easy. But I think this is one where we should, so we have x cubed, 3x cubed y squared. I'm just bringing the 3 out front, dy dx minus dy dx is equal to negative 3x squared y cubed. So, and then I can't forget about the 1 here. So 1 minus, so when I pull that over here, it'd be 1 minus that. So I just brought the 3 out front and did x first instead of y. Now let's factor out a dy dx. You have to be careful here. This is a common mistake. So 3x cubed y squared. What happens if you factor a dy dx out of a dy dx? Does it just go away? No, that's a common mistake. Divide dy dx by dy dx and you get 1. And now we're down to the last step. Dy dx is equal to 1 minus 3x squared y cubed over 3x cubed y squared minus 1. All right, I want to check my answers. Make sure I didn't give you something wrong here. 3x squared over 3y cubed. Yep, that is right. Okay, brilliant. All right, that's a good problem. That's, you know, you can kind of expect a problem of that difficulty or so on the test. You know, not the easiest one, not the hardest one. Okay, number 8. We have root xy is equal to x minus 2y. And I said, you know, let's consider rewriting this as x to the 1/2 times y to the 1/2. Or you could rewrite it like this, xy all to the 1/2. Either way. But since I mentioned doing it this way, that's the way we'll do it, is equal to x minus 2y And we need to ddx that. So we have the first, x to the 1/2, times the derivative of the second, 1/2 y to the minus 1/2, times dy dx. Remember, anytime you got to take the derivative of the block, which is the y, anytime you do that, doing that, plus the second, y to the 1/2, times the derivative of the first, 1/2 x to the minus 1/2, is equal to, what's the derivative of x? It's 1. And the derivative of 2y would be minus 2 dy dx. Okay, so pretty nasty. I am going to go ahead and let's go ahead and rewrite this as root x over 2 root y dy dx. So what I did was I brought the y to the negative 1/2 down the bottom, left the 2 on the bottom, plus root y over 2 root x is equal to 1 minus 2 times dy dx. Okay, going to gather all the dy dx terms on the left. So I've got root x over 2 root y dy dx plus 2 dy dx is equal to 1 minus root y over 2 root x. Going to factor out a dy dx here. And I would have root x over 2 root y plus 2 equals 1 minus root y over 2 root x. And finally, our last step, solving for dy dx. I'm going to have, in fact, let's move that up here. Dy dx equals 1 minus root y over 2 root x over root x over 2 root y plus 2. All right, so I don't make you simplify that, because usually I'm asking for the slope of a tangent line at a point, and you would just plug numbers in here. So you wouldn't have to make a common denominator and all that jazz. If you went this route, okay, you would get the same answer but in a different form. So I want to go ahead and give that to you. If you went this route, the way the answer would look, even though it is the same answer, 2 times root xy minus y over x plus 4 times root xy. That is the same answer. It's just a simplified version of this. So if you wrote it that way and then took the derivative of this using 1/2 xy to the minus 1/2 and then did a product rule, you would end up with this. But they are the same. Okay, number 8. So number 8 I think was the toughest one on the homework. Number 9. We have x cubed minus 2x squared y plus 3xy squared equals 38. So we're back to having a constant on the right. Okay, we want to take the derivative with respect to x of that thing. So it's going to be 3x squared minus, we have a product rule and a minus, so I better put parentheses around all this. the first, 2x squared, times the derivative of y, that's dy dx, plus the second, y, times the derivative of 2x squared, which would be 4x, plus, now I'm not going to put parentheses around it because it's a plus, so I'm not going to mess up in the distribution. So it would be the first, 3x, times 2y dy dx, plus the second, y squared, times 3. The second times the derivative of 3x, which is 3. Now I'm leaving it like this on purpose. I'll clean it up in a second. Is equal to 0. So I've got 3x squared minus 2x squared dy dx. Now I'll clean it up. Minus 4xy. That's the better way to write that. Plus 3 times 2 would be 6xy dy dx, plus 3y squared is equal to 0. Now let's put the dy dx's on the left. And then on the right, we're going to move, we're going to have I'm going to put the positive one first, so I'm going to move the 4xy and make it positive. Minus 3x squared minus 3y squared. So that, and that would move over and change the sign. Oops. I'm not making a fraction yet, sorry. It equals that. Okay, so now let's factor out a dy dx. I got negative 2x squared plus 6xy is equal to 4xy minus 3x squared minus 3y squared. So dy dx, we're going to bring this left side underneath the right side. So 4xy minus 3x squared minus 3y squared over, I'll put the positive term first, 6xy minus 2x squared. The back of the book would do that, I believe. So let me double check my answer. Got the 4xy, negative 3x squared, negative 3y squared on top, 6xy minus 2x squared. And it doesn't matter if you have the negatives first and then plus this. And if you had negative 2x squared plus 6xy, that's the same thing. So no problem. It's better form, I think, to put the positive one first. All right, that'll do it for this homework. Pretty fancy, but once you get used to it, not bad at all. All right, talk to you next lecture.